using routers with jigs, and particularly about dovetail jigs. The majority of this will be referenced dovetail jigs. And router was built, actually invented in the 1920s. And I'm sure that R.L. Carter, who invented it in Syracuse, New York, probably was using his shaper one day and thought, wouldn't it be neat if I could pick my shaper up and turn it upside down and carry it over with a bit in it to the work and do some useful work. It proved to be a very useful device, and R.L. Carter sold about, I believe, 100,000 routers before he sold the idea to the Stanley Company, who in turn sold it later, and it's really the Bosch line of routers is the result of all that. Probably 15 years ago, there was the invasion of the plunge router and high horsepower routers up in the 3 horsepower range. At any rate, people took these 3 horsepower routers and they said, you know, if I just mounted this in a table, then I'd have myself a small shaper. But the difference between a jig and a fixture is a jig guides the tool. On the other hand, if we made the router stationary and we attach the work to a fixture and move the work around, it would be properly called a fixture. So that's the difference between a jig and a fixture. Jig guides the tool, fixture guides the work. And I think jigs and fixtures are more a way of thinking. Let's talk a little bit about the dovetail. And of course, dovetails were and still are cut by hand. And hand cutting is still a very acceptable way to do it. The problem arises, let's put skill aside for a moment. I think that most people think they can't hand cut dovetails because they don't have the skill. I don't believe that's true. Every one of you has the skill to hand cut a dovetail. And if you'd stick with it, about 12 sets of dovetails and you'd be cutting them swimmingly. But most people have the feeling that the machine is going to replace skill. And as I alluded to yesterday, the history of craftsmanship has been one of going from workmanship of risk to workmanship of certainty. And that's an idea laid out by David Pye in England. And so everything you see a new thing, what they're really selling you is workmanship of certainty. You go to a woodworking show and they've got all these gizmos and they're telling you you won't have to worry about this anymore. And that's largely the history of craftsmanship, no less the dovetail jig. I will say, however, that I think the learning curve to use any of the dovetail jigs well is probably not vastly different from learning to hand cut. We can see that having a nice fit in a glue joint is a wonderful thing. And this is where jigs, I would say, outperform hand cutting in that you get glue area surfaces out of jigs that are fairly incredible, especially if they're set up right. The nice part about this joint is that it's moving in conjunction with each other, that these two masses of wood all tend to move in about the same speed and direction, and so there isn't a lot of working of the glue joint. Now there's 3 kinds of dovetails, and in a through dovetail it's exposed, and that if you look at the outside of the box on any face, you can see the pins and tails. In drawers, we often want to conceal the joint. I don't have a drawer here, but in a drawer, we'd use what's called a half-blind dovetail, and I think I have some pieces of wood here that we could show it with. And we'd take a relatively thinner piece and a relatively thicker piece, and we'd dovetail this in and conceal the joint from the face of the drawer. And that's called a half-blind dovetail. There's a full-blind dovetail, or secret dovetail, which is totally hidden from both faces. They can be made with machines, incidentally, and they can be hand cut. And the reason for cutting them are a couple. One is if you've seen any of these little Victorian writing boxes that are all veneered and often split at an angle and nice looking contraptions. If you try to veneer over a dovetail that as everything moves, it will show through. The other place they're used is in 18th century furniture for what's called an OG bracket foot, which looks something like this. And these would be secret dovetailed together so that it wouldn't show from the outside. And that's like the front of a the foot of a fall front desk would have that kind of a joint in it. A rule of thumb for the length of the tails when you're hand or machine cutting, that it should be between 2/3 and 3/4. The length of them should be 2/3 to 3/4 of the thickness of the face material. How drawers were made in hand dovetailing days with solid wood construction. And in a solid wood drawer, if we look at the back of it, and we'd have our half-blind dovetails here, traditionally the back of the drawer was made a 1/2 inch narrower than the front, like so. So this would be a 1/2 inch here. And then a groove, a 1/4 inch groove was plowed right here, and then the bottom slid in under the back. And the grain of the back was aligned like this. So the grain is not going to change the width of the drawer ever because it doesn't change along the grain. And they solved the expansion and contraction problem by making quite a deep groove in the front of the drawer and not feeding it all the way. And then generally in early America, they would just use a light wire nail right there. And a wire nail's forgiving enough that if you did expand in really wet weather to where you bottomed out in the front groove, the nail would give a little. And also the back of the drawer would bow a little. So it was very forgiving. The arts and crafts people around 1900 did a little more elegant solution. They would take the back of the drawer and cut a little slot in it. So this would be if you're looking at the drawer upside down, and then they'd put a flathead wood screw in here, and this would give it some more ability to expand and contract without hurting anything. It's what I do with my drawers when I build solid wood construction. In the late 19th century, plywood came along, and plywood, because the layers turn at 90 degrees from each other, really doesn't expand and contract very much. It stays about the same all the time. And so you could go to a drawer in which the back was the same dimension as the front. You essentially built a box, and you simply trapped a piece of plywood in for the bottom in a groove when you assemble the drawer. That's the way kitchen drawers, most drawers are built today. And so this eliminated the need to go to a through dovetail here in the back. And so most drawers today, when you look at them, if you look at a side view, you've got half-blind dovetails on both ends with a thicker front and a thicker back than the sides. Sides are generally 1/2 inch, with the front and back being 5/8 to 3/4 somewhere. So with this simple industrial revolution type of jig, you could suddenly just cut a bunch of pieces, stick them all in the jig, and away you go. If you're going to make one drawer or two drawers, and they're going to be an 18th century style, or really anywhere up to early 20th century with a solid wood bottom, that you may find that you can hand cut them just about as fast as you can machine cut them. And it comes down to your enthusiasm for machines or hand. And then finally, the other thing is that if you're going to really do a lot of this, it's really worth having your router set up permanently for the jig so that you can just sort of walk over and do it. With the Porter cable jig, we have a cheap router sitting there on top of it with the bit in it, the guide bushing and everything else, and we just go to town. And so the only thing you really do is adjust the combs and kind of figure out the right spacing. Normally you don't use what's called a guide bushing in a router. This is a guide bushing. When you want to use a router with a jig to guide the bit, there's a couple ways we guide bits. Of course, we're all familiar with the bits that have a bearing on the end of it, and the bearing touches your wood and makes it cut to a certain depth. And there are some jigs that use bearings instead of guide bushings. The Keller jig particularly puts a bearing on the shaft of the router bit like this, and this allows this bit to be guided by the jig without having to do anything but put it in the router. Pass that one around too. That's from a Keller jig. But mostly, and this dates again from the Industrial Revolution, what's called a guide bushing is used. And with a guide bushing, we can put this in the router, and then the router bit is going to go through it like so. And this guide bushing is going to guide the router around the combs of the jig. Now, mostly if you're having problems with a jig cutting the way it's supposed to or advertised to, it's mostly traceable to guide bushings 9 times out of 10. Guide bushings are so critical that in the early days the Lee people actually went into the manufacture of their own guide bushings because they couldn't get the consistency they needed from most manufacturers. And there's a couple of problems here. You'll find that some manufacturers, since routers are such a worldwide commodity, and we're the only place left on Earth where we still use the decimal English system, that a lot of bushings, like say a half-inch bushing, you'll find is really a 13-millimeter bushing that's been relabeled half-inch. And the Lee dovetail jig in particular, well, the Akita jig as well, and Porter cable jigs are all set up or built on the English system. So the guide bushings really do have to be in the guide English system. Porter cable, of course, uses their own bushings, and they know what size they are, and so you don't tend to have too much problem with the Porter cable jigs if you use Porter cable bushings. Porter cable, I think, is the de facto standard in the U.S. for guide bushings, and that most of the other fancy guide bushings you see are sort of copies of those. This is the system that's been out for about 5 or 10 years from Bosch, which is another system. And Bosch guide bushings seem to be very good. And this one, it's a bayonet mount. We simply drop the guide bushing down in place and release that, and it's now locked in place. And that can ride on the face of the jig. Another problem with guide bushings you have to be careful of is if you buy some guide bushings, they're too long. And we'll cover this in a little more detail, but in the Lee jig, there's a comb here. And there's what they call icons right here. And they tell you what type of joint, part of the joint you're cutting. But if you look very carefully, the top half of this finger is different from the bottom half. So the guide bushing, when you put your router down on this, can only go half the distance of this finger, or it's going to pick up the other pattern that's on the bottom and screw you up. So if you're having trouble with a Lee jig and it's not doing it anywhere near, make sure your guide bushing isn't too long and is unwittingly picking up the other half of the finger. So guide bushings, very, very important. Yeah, that's the other tremendous problem with jigs is not having a concentric, a router in which the bushing goes concentric to the shaft of the router bit. And if it's off center, of course, what you end up with very often is the fact that the work doesn't center up, that one of the pieces comes out a little offset from the other. you should form the habit of always holding the router the same way, and there's usually a router is usually meant to have a certain side towards you, and for this one, all this is here, and the switch is conveniently located and so on. And you shouldn't hold it backwards in the jig or anything like that, because you're now sort of exacerbating that problem. By holding it the same way, at least you'll keep the error constant.